What is the difference between hypothesis and a theory? When one thinks of a hypothesis, one can use a hypothetical case that may not be real or exist. One could always use the hypothesis in order to help solve a problem. For an example, when you want to measure the velocity of a photon, for an example, or a wave packet, it is impossible for us, since we are material subjects or material beings, when you make a measurement on a wave packet or a photon, you interfere with it. In order to measure velocity, one would have to have two positions, a position x1 and a position x2. You have to have also two times, a time t1 and a time t2, in order to come up with velocity. So if a wave packet happens to be moving faster than the velocity of light, if you stick your measuring instrument out in the path of this photon, what happens, a mirror or a window would interfere with that photon. You get a forward scattering or an interference would take place. And what happens, you will actually annihilate or you extinguish the primary photon. And from that point on, you have created a secondary photon. So you killed the first primary photon. You measured, you have detected x1, but x2 you will fail to detect, and also the time t2 you will fail to detect. So it is therefore, it is physically impossible to measure the velocity or the wavelength of a primary photon without annihilating it. So this is for this reason, to this date, that the velocity of electromagnetic radiation has not been measured successfully. One has assumed that relativity claims that the velocity is constant in all frames of reference, which is not true. So we have not measured successfully the primary photon.
Okay, and when we take that back to the question, which is hypothetical or?
That is that use of hypothetical instead of theory.
Right.
So a theory, when we describe an experiment, we come up with a theoretical interpretation of that experiment and use hypothesis in order to help explain the method, the occurrence in nature, what took place in nature. That is, we use a hypothetical case.
I got it.
The only thing we do, we use a hypothetical case on it.
That's good.
Yeah.
That's cool. I'm getting it.
So all the photons that are reflected off the surface are no longer the original?
That's right, that's right, that's right. So that photon coming off of the back of a window or coming from a mirror, it's not the same photon, it's a secondary photon. The primary photon is been absorbed by the mirror, and the mirror becomes a secondary source, producing a secondary photon. That's right.
So you're going to have to develop a whole new...
The whole universe is an illusion.
That's right.
Because all these photons are traveling through plasma.
That's right, exactly. Are some of the really big issues less settled than commonly claimed? And the answer to that question, the first part has to do with gravitational lensing. And the subject matter of gravitational lensing is far from being settled. As you look at the solar system and the nearest star to us, our sun, around the limb of the sun, there is what is known as a plasma limb. And there has been, for the last century, the observation of what is known as gravitational lensing or gravitational light bending at the limb of the sun. And that can be settled because one could easily calculate, based on the gravitational gradient acting on the plasma limb of the sun, that light will actually bend taking a minimum energy path or minimum time path through that length. And when we come up with the same Lindsay 1.76 arcsecond, what relativity claims to have because of relativistic effects. One can claim this effect has to do with the minimum energy path, or the scattering or light bending having to do with the effects of bending due to refraction of the plasma itself. Nothing to do with relativistic effects at all.
So, next question, sir.
Next question. Who has the authority to declare a scientific question settled? And the answer to that, I feel, should not be who has the authority, it should be what. And the what, in this case, is the experiment. So if you have an experiment that you can have a lot of measurements in an experiment, you can measure 10,000 times or 10,000 experiments. And some theory could pass 10,000 experiments, but if it fails one, then the theory is history. So the answer in this case should be if the experiment is done using proper scientific method, and the scientific method is adhered to, the scientific method should be the correct authority over deciding a theory. And you have many theories. You could have two identical theories, two theories that describe the same thing. But once a theory fails an experiment, then that theory should be history. Relativity has failed many.
You slid that one in, yes.
Right. I think I was going to make that note.